Number 12. A ball with mass m projected horizontally up the end of a table with initial kinetic energy k. At the time t after it leaves the end of the table, it has kinetic energy 3k. What is time it takes? And we can ignore the air resistance. The fact that we can ignore the air resistance means the energy is simply converted from one form to another. Therefore, we can apply the energy conservation theorem. Let's first draw our diagram that represent our system. So we have a ball with certain mass m, has a certain initial velocity, and after a while it's gonna make a projectile, and at one point the ball is gonna have the 3 times the initial kinetic energy, and that's gonna be our final reference. And for now we're gonna set that to be h2 and the top height to be h1. So this doesn't necessarily mean that our ball is hitting the ground in the final position. And we are interested in the change in height for now. And let's use our energy conservation equation. So initially we have kinetic and final potential energy, but the problem said we have final kinetic energy has 3 times the initial kinetic energy. That means we can simply plug this into our equation. So you have 3ki plus, okay, for our potential energy we're gonna have mg h2 equals mg h1 plus initial kinetic energy. Now we can subtract initial kinetic energy on both sides. So that leaves me mg h1 equals 2 times the kinetic energy plus mg h2. Okay, I'm gonna have the mg h2 minus mg h1 because this represents our final and initial height. So that ultimately is gonna yield us the change in height. But for now, let's simplify our equation. So I can now distribute this. Divide both sides by mg, so I get okay. So far we identified the height, and now we can use a simple kinematic in the y component of our projectile motion. The x direction is irrelevant because there's no net acceleration that caused our potential energy to convert to the kinetic energy. Therefore, we are only concerned with the y component. And let's write down our given. Initially it doesn't move, and acceleration is negative g, since I'm going to call this the negative side. Negative acceleration downward, and we have height delta h we just calculated that turned out to be this guy. So negative 2k minus over mg, and ultimately we have to find time it takes. We use the y component equation. We do know that initially in the y direction there is no velocity, and just plug in the value. Now, the minus cancel out, and I can multiply 2 on both sides, so 4 times the kinetic energy over mg. Okay, now I divide it by g. That way, on the right side, I only have t squared. Okay, let me check that. 4 ke mg. Okay, and to find the time, I just have to square root on both sides. And we can disregard the negative time. And we get, oh, don't forget the squared for our gravity, because on the left side I have a g times g, that makes it g squared. So 4 can be simplified as 2 out of the radical sign, and ke, and m has to be inside the radical sign, and g can come out. Do we have the answer? Okay, the ke is basically k. I just chose ke. K over m, and 2 times 2 over g. Answer is B.